Hello, I welcome you all to this another interesting screencast, and the problem reads determine the force in each member of the double scissors truss in terms of the load P and state if the members are in tension or compression. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Okay, right. So let's inspect our truss. We have a scissor truss and we have 2-point loads at joint E and F. We have a hinge at A and the roller support at D. When you look at this, there is some symmetry about that axis there. Okay, so we have symmetry both the load as well as the geometry. So we have symmetry for both cases. Okay, so if we have symmetry, then it means we expect, if we are to write the support reactions, let's write a free body diagram. We have AY, we have AX, and then we have DY. Great. So we expect the support reactions in the vertical direction AY to be equal to DY, AY to be equal to DY, okay, because of symmetry. The member forces, we expect force AB to be equal to, member force AB to be equal to DC or CD, okay? And then member force AC to be equal to DB or BD, okay? And member force EC to be equal to FB. And then member force AE to be equal to DF. All right. Is that fine? It is. So we expect this occurrence, okay, which makes the problem much easier. So then it means we are only going to concentrate on few joints because we know that we have symmetry and members will have the same forces in the other members. So we are just going to concentrate on few joints. All right. First and foremost, let's find the support reactions because we are going to use one of the supports to also find some member forces. So let's say summation of moments about point A. Okay, summation of moments about point A equal to 0. Right. So what do we have? We have a minus P times, this is a minus moment clockwise, right, by L over 3. Okay, then we have another negative moment due to P. This one is 2L over 3. Then plus dy by L over 3 by 3, that is just L, equal to 0. Therefore, our dy is just going to be equal to, so we have minus PL over 3 minus PL over 3. This becomes 3PL over 3. Okay. Then once we divide the L there, 3 and 3 cancels out. Then we'll have dy equal to P. Okay. Okay, then we have summation of forces in the Y equal to 0. Going up in our reference, what do we have? We have AY minus P plus dy equal to 0. We just found what dy is, so let's replace it there, and once we do so, we'll find that our AY will also be equal to P. Okay, Then we have summation of forces in the x direction equal to 0. In this direction being our reference. Therefore, our AX is just going to be equal to 0. Great. Okay. So now let's begin the work. So let me create a boundary here before we start doing the work. Okay. So which one do we start with? Of course, we want to start with a joint that will give us less work. It's up to you to pick which of that joint. We're going to use the joint method. So for me, I'll go for either joint E or F. Okay, joint E and F will give us the similar results. So let me go for joint F. Okay, joint F. Why joint F? Because joint F, I'll be able to get the component of BF or FB. And once I have BF or FB, then I can go to joint B. And then once I go to joint B, since I will have already found the value of BF, I'll be able to find the other components AB and BD. Of course, there I'll need to solve two equations simultaneously. And once I find AB and BD, then I'll move to A. I'll move to A or D. Doesn't matter, I'll move to A. Once I go to A, my aim will be to find AE. AE, which is equal to FD, right? Or DF. Alright, and then since I'll have FD, then I'll be able to find FE or EF, because this is the only one that is not paired like the others, right? Great. So here we are, there we are. We have P down like so. This is joint F. Then let's say this one is in tension. This is the one we call DF or FD. Then this other one is let's assume it also to be in tension. Let's call it EF or FE. Okay. And then this other one there, this other one like so. Let's call this one, we called it what? This one we called it FB, right? Okay. So this one will have components. This one will have components. Let's find out these angles. We have this angle here, we are calling theta. Okay. And then we have this other angle here, I'm going to call alpha. Alright. This one here is theta. Okay. Alright. So what is our theta equal to? Look at theta. Theta is equal to 45 because our EF is equal to L over 3 and the EB is also equal to L over 3. Seen this? So since the lengths are equal, what do you think the angle is supposed to be? Alright, it is 45, right? Do you agree? Of course you should agree. Alright, so that is our theta. So we are saying our theta is equal to 45. Okay, I'll write it here on top. Alright, of course this is also alpha, right? This is also alpha. Okay. Alright. What is this alpha here? Let's find alpha. What is alpha? So we know that alpha, just write it down. Alpha is going to be equal to tan inverse of this height, this opposite is CF, right? What is CF? Is L over 3 divided by what is AF, okay? It is 2L over 3. So L and L cancels. So we have 1 over 3. Grab your calculator. Around 1 over 3 divided by 1 over 3 divided by 2/3, and then tan inverse of that, we get a 26.57, right? Is that fine? 26.57, great. So this value here is 26.57. 26.57. We can write it down there. So alpha is equal to 26.57. Great. So with those angles there, then we'll have made our life easier. Can I wrap this? Thank you. Great. So this angle here, we said is a 45. Therefore, we'll have two components from FB. We'll have this component here, which is FB sine 45. And then I'll have this other component here. Okay. This one is FB cos 45. Great. What else? That's all for now. So say summation of forces in the y direction equal to 0. What do we have? We have minus P and then plus FB sine 45, right, equal to 0. Therefore, my FB is just going to be equal to P divided by sine 45. Okay. I want to leave it like this for now so that I don't have decimals so much. I'll finalize it later on. Right, so we have FB equal to P over sine 45, right? And then the other equation, we are saying summation of forces in the x direction equal to 0, like so. That one we have minus FB cos 45 plus minus EF plus DF equal to 0. So come and work out this equation later on once we find what DF is, right? Once we find what DF is, and we'll find DF by just finding AE, okay? So let me close the gap there, like so. I close the gap like so. So we are done with joint F, and we found FB, so we can go to joint B. Okay. We can go to joint B. So joint B, we have FB itself, which is just equal to P divided by sine 45, and then let's assume these are in compression. You can assume this to be in compression as well as this one. Okay, so this one we say this AB, and then this one is DB, right? Okay, right, so we know the angle for this force here. It will have two components. Let's start with this one. So we'll have this component in this direction like this, and another component like that. Okay, right, so we do know the angle for this. The angle for this is this angle here. Okay, this angle here. We know this angle here for this particular, this one here, it is 45 degrees. Therefore, this force is P over sine 45 times cos 45, right? Okay, and then this one here is just equal to P divided by sine 45 times sine 45. Okay, we just remove the brackets there, we don't need them. Great, so that is about it. And then let's get the components of AB. I'll use green. We know this angle also for AB. This angle here is 45. Okay, so AB here is just going to be equal to AB cos 45, and then we'll have another component in this direction, like this. Let me just move this a little bit further. I write this properly. So we said this is where is the blue? So we said P divided by sine 45, then this one by sine 45, and then we have another component for AB. So this one we are saying is equal to AB sine 45. Then we have another component for dB. Okay, there is this force here we are calling dB. Okay, let me write it somewhere here, maybe down like so. This is dB. dB is going to have some components also in this direction like this. This one there, and let's say another one there. All right, and the angle for dB, this one here is alpha. Okay, and what is alpha? Alpha is equal to, let me use green there. Alpha, we found this one is alpha, right? This one is alpha here. Okay, this is alpha, and we found what alpha is. Alpha is 26.57. This one here, see? So just replace it there. So this is dB. dB sine 26.57, and then this one is dB cos 26.57. Right, I think we have everything. This joint here is B. So we generate two equations from this. Let's go ahead. So let's start with summation of forces. Doesn't matter which direction you start because you still have unknowns. Summation of forces in the y direction. What do we have in the y? We have dB. Let's start with dB. Okay, let me start with AB. AB sine 45 plus dB sine 26.57, and then minus P. This sine and sine will cancel, so it's just minus P. You've seen this and this will cancel, right? Okay, minus P. Are we there? Sine and sine will cancel, so I'm just writing the result in advance C. Okay, so minus P equal to 0. Alright, so if I was to make AB subject to the formula, AB will be equal to sine 26.57 divided by sine 45. So this gives us a minus 0.6327. 6326, 6326 dB, and then plus P divided by sine 45. Okay, then we have summation of forces in the x direction equal to 0. In this direction being our reference, what do we have? We have AB cos 45. Okay, and then we have another minus dB cos 26.57, and then we have plus this sine 45 and cos 45. Since sine 45 is equal to cos 45, that is also a p. You've seen that one? So I'll just put a p here. Okay, is that fine? Great. Equal to 0. So AB here will give us, it will be equal to AB will be equal to we divide cos 26.57 divided by cos 45. So this gives us a 1.2649 dB, and then we have a minus P divided by cos 45. So we're going to solve these equations. We'll solve them simultaneously so that we find the values of AB as well as dB in terms of P. So if we did so, then we'll find that our dB is going to be equal to, let's solve that one. So if we equate them, then we are going to have the following solution. We'll have the following solution. Just 1 minute. Okay, so say 1.4906 should be like that, maybe P. Okay, I think I make it like that. Should not be quick to round off because I'm transferring errors. So let's find AB. So minus 0.6326 times 1.4906, okay, plus 1 divided by sine 45 gives us a 0.4713 P. Let me check the other one there. 1.2649 times 1.4906 minus 1 divided by 1.2649 times 1.4906 minus 1 divided by cos 45, 0.4712. Great, this is fine. This is great. Alright, these are promising values. They are great. So we found dB, we found AB. What else do we need? So now we have to go to joint A. We have to go to joint A. Great. Let's go to joint A. Okay. Joint A, we want to find AE. Alright. Mind you, we found all the values. I mean, not all the values. We found most of the values. Okay, I wanted to move the whole lot of this. Why is it not moving? Great, something like that. I move it there just for the sake of space. Great. Okay, this is DF. So found most of the values. So what we want to find now is AE. We need to find AE. And once we find AE, then we'll find everything. Great. So let's go to joint A. Okay, either joint A or joint D will do the same job. Okay, this one we had called it joint F, right? Great. So that is joint A. What do we have? Let's say this one is in tension. Which one is this? This one is AE. Okay. And then we have the support there, which is a P. And then we found what AB is, and it's in compression. Both of these are in compression. I didn't just indicate down there, they're in compression. AB and DB. So we'll have AB coming in like so. And this value is equal to 0.4713p. Okay, and this angle there, it is 45. Before I even indicate the angle, let me also indicate the other one. We also have AC, and AC is practically equal to dB. We already found it also, that's AC. Okay, AC is equal to dB, right? And what's our dB? It is what is our dB? Our dB is equal to 1.4906 Great. Okay, and then this one, of course, this is okay, AE. Right, this is our alpha, and then we have our theta. Okay, so we know those angles, right? We use blue colored. I think it's fine, just like that. It's fine. So we know those angles. So let's find the components for each one of those. We'll have this component and this component for 0.4713p cos theta, which is a 45, right? Theta is 45. And then this one is 0.4713p sine 45. Alright, then we'll have another component for this other force, which is a 1.4906p sine alpha, which is a 26.57. Okay, and then we'll have another component there like so. So this is 1.4906p cos 26.57. Maybe I should write it. It's too long. Let me write it inside there. I'll say 1.4906p cos 26.57. This one. Great. So we have all the components that we need, but we are just interested in AE. So just say summation of forces in the x direction equal to 0, in that direction being our reference. So we have AE like so, minus 1.4906p cos 26.57 minus 0. This other one 0.4713 cos 45 equal to 0. AE therefore is just equal to let's find it. It's 1.4906. 1.4906 cos 26.57, okay, plus 0.4713 cos 45. Then we have a value of 1.6664p, and it is in tension. So 1.4906 cos 26.57 plus 0.4713 cos 45, 1664. Great. So we have this value for AEE. So what we need to find now, since AE, we said AE is equal to DF. So we'll get this equation. Remember this equation, this one here. Okay, we'll get that equation. So we'll get this equation. I'll just draw an arrow here. We'll get this equation and we'll bring it here, and to solve this one, we'll bring it here. Okay, so this equation is, in fact, okay, that's there. So we said minus FB cos 45 minus EF plus DF is equal to 0. Alright, let's move it a little bit down. We move it here. We can change our arrow and bring it there like so. Great. So we have that, and we already know most of the values. FB is equal to, let me write down here, EC, where is it? AE is equal to DF. What is AE? Is 1.6664, okay, P. All right. No space. This line is not good enough. We have to bring these things like this, something like that. Great. So we said AE is equal to DF, which is equal to 1 point is equal to, this is equal to 1.6664p, and it is in tension. So we know this value already. DF, this DF is equal to AE, which is equal to 1.6664p. So, and then we know EF. No, we don't know EF. We know FB. We know FB. FB is equal to P divided by sine 45. Our EF therefore is going to be equal to, we have P divided by sine 45 by cos 45, which is just a P, so that is just a negative 1 plus 1.6664. Right, so it gives us EF is equal to 0.6664p, and it is in tension. Great. So let's have a quick summary here. Let's have a quick summary of everything. Great. Okay. So we have AE equal to DF, and then down here I'll put EF. Alright. So I'll just be writing this in two decimal places. AY is equal to DY, which we found. This we found is equal to P. This one was equal to P. This one equal to 0. Okay. Equal to 0. Therefore, here it is just P. And then AB, which is equal to DC, we found AB just equal to 0.47. That's 47. Just 2 decimal places for now, P, and it is in compression. AC is equal to dB. Where is dB? AC is equal to dB, and dB is just equal to 1.49 P, and it is in compression. Okay. And then we have EC. EC equal to, where is EC? EC is just equal to BF. Where is BF? BF is P over sine 45. So 1 over sine 45 gives us just a 1.41 P, and it is BF, it is in tension. This is in tension. This is in tension. Okay, so this is going to be in tension. Okay, this is in tension. All right, and then AE is equal to, where is our AE? AE is equal to FD. AE, we just calculated AE is a 1.67 P, and it is in tension. And then finally EF is just equal to 0.67 P, and it is also in tension. Great. So let me just outline again these final solutions. Okay, we have EF there, then AE here. Okay, and then we have AB here. Okay, and then we have DB there. Okay, and then finally we have FB. Okay, what else? I think this is really about it. And I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screen.